Hello students, how are you? I hope you are well and safe. I welcome all of you in this education platform. Now in today's class, we will discuss about the chapter chemical bonding and molecular structure. Students, let me tell you, this is most important unit of the entire class 11th. It is very important chapter. As far as any competitive exam is concerned, it is really a very important unit. In this unit, the first segment that we shall discuss today is Introduction to Chemical Bond. Here I will teach you how many type of bonds are there, how these bonds are formed, what is the requirement of bond formation, and few more questions related with the bond formation. So let's come and study this Introduction to Chemical Bond. So today in this section where we will introduce the new chapter, and this is the first session of this new chapter, Introduction to Chemical Bond. In this unit, we will discuss so many things related to the chemical bond. Chemical bonds are very important. How these bonds are formed, why these bonds are formed, what is the mechanism behind the formation of these bonds. These all questions will be answered in this unit. Today I will also tell you about the octet rule, Lewis approach, and causal approach towards the atom. So this will become a very interesting class. Let us start the class. These are the different concepts that we shall discuss in today's module. So today's session will give you idea about the introduction, chemical bond, Lewis and causal approach of atom. Then we shall study about the Lewis symbols. What do we mean by Lewis symbol? What are the Lewis symbol? Then we will study the causal approach towards the formation of bond. And then finally octet rule. So if I ask you a very simple question, why atoms they combine together by a chemical bond? Why do we need to form a bond? Why atoms form bond? See, if I ask you a very simple question, why we humans, why we live together? Why we live together in a family? Because in the members of the family, there is a strong bond of love and affection between the members. And that affection keeps the family member together. It does not let us apart from each other. This is what the bond of love and affection between the members of family. As like the members of family, the same kind of force of attraction exists between atoms. You know, imagine what will happen if you live alone. If you will try to live alone, very soon you will get bored of your life. In order to keep ourselves more stable, we'll live in a family. So basically, in a similar way, atoms cannot exist freely. They also combine with another atom to form the molecule. So what is molecule? Molecule is the group of atoms. Students, group of atoms is called as molecule. Now you see in this example, in the presence of oxygen molecule and hydrogen molecule, atoms, in presence of the oxygen atom and hydrogen atom, there is a formation of molecule, which is a water molecule, in which there is a bond between oxygen and hydrogen and another oxygen and hydrogen. So there is another bond. These bonds exist between oxygen and two different hydrogens. So this is why we form the bond. Now, what is chemical bond? If I ask you a definition, as per the definition, what is chemical bond? So chemical bond is the attractive force which hold various constituents like atoms or sometimes ions together in a different chemical species called as chemical bond. So It is a force of attraction which holds these species together. Primarily, although chemical bonds is of many types, but primarily chemical bond can be categorized into two major categories. One is ionic bond, another is covalent bond. Ionic bond is very simple. It is simply transfer of electron from one to another species. See, if electron is transferred from one to another species N, then there will be a formation of M plus and there will be a formation of N minus. And the force of attraction which will exist between M plus and N minus will be ionic bond. So the force of attraction between cation and anion is called as ionic bond. While covalent bond is simply sharing of electron. It is simply formed by the sharing of electron. Don't worry students, in this unit we shall study both of them in complete detail. But in today's session, let us study how these bonds are formed. So to learn about the bond and the formation and to understand more about the structure, many theories have been put forward by the different scientists, like Coastal and Lewis approach towards the atom, VSEPR theory, it is valence shell electron pair repulsion theory. The other theory is the valence bond theory, VBT, valence bond theory. And there is one more theory which is also used to explain formation of bond, which is MOT, named molecular orbital theory. So these are the different approaches by which we study the molecules. So first, in today's session, we shall start with the Lewis and Coastal approach. So a number of attempts were made by the different scientists to explain the formation of chemical bond. See students, you are living in 2021. You already know that how these chemical bonds are formed. What about 100 years before? We were not having any idea how these bonds are formed. So we did the various attempts to explain the bonding. In 1916, approximately more than 100 years from now, Coastal and Lewis, they were two different scientists, they succeeded independently. What do we mean by independently? It means they were working separately, not in a single geographical area, same geographic area. They were working separately and they gave the satisfactory explanation for the formation of bond. They were the first to provide some logical explanation of valence electron, which was based upon the inertness of noble gas. Do you have any idea what is the inertness of noble gas? Noble gases like helium, neon, argon, xenon, krypton and radon, because of their completely filled outer orbital, which is P6, which is completely filled, they are comparatively inert. So approach of bond was first explained by Coastal and Lewis, 1916. Now what they gave? Lewis said the atom in terms of the positively charged kernel. So basically he represented the atom in the form of the positively charged kernel. You must be thinking students, what is this kernel? In any species, suppose any species is there in front of you, nucleus and the outer shells, say for example, doesn't matter how many of them are there, but if you remove the outer shell, just outer shell, then remaining part of atom is called as kernel. So kernel is, in simple language, what is kernel? Kernel is atom, any atom minus outer shell. When electrons are removed from the outer shell totally, all the electrons which are present in the outer shells, they have been removed, and if the all electrons from the outer shell are removed, remaining part is called as kernel. So this Lewis represented that kernel and the outer shell that could accommodate maximum of 8 electrons. Later it was called as the octet rule, means outer shell of any atom can accommodate maximum of 8 electrons. This is what octet rule says, that it can have maximum of 8 electrons. See, it is right or wrong, that is another point of debate that we shall see in the coming lectures. Now, according to the Lewis postulate, atoms achieve the stable octet when they are linked with the chemical bond. So students, this is the purpose. If someday I ask you, what is the purpose of bond formation? See, anything we do, everywhere we go, whatever we do it on a purpose. There is always a purpose, might be a small purpose or a big purpose, but there is always a purpose. So according to the Lewis postulate, atoms, they achieve the stable octet, means whenever they have 8 electrons in their outer shell, their configuration becomes equal to the inert gas and they are said to be stable. So everyone wants to go into the stability, whether it is you, me, or any other human being. We all want to get stable in our life. No one wants unstable life. Same like the atom. They also want stability. But in terms of the atom, stability is quite related with the energy. As far as the human is concerned, stability is, for most of the time, it is attached with the finances. In terms of human, most of the time, stability, when I say stability, it means financial stability. Not always, but most of the time. But for the atoms, whenever I say stability, it means it should be there in terms of the energy. Lesser the energy, greater will be the stability of atom or the molecule or the species. Now in case of sodium and chloride, a stable octet is achieved by the transfer of an electron from sodium to chlorine by giving electron. So there is a formation of Na plus by the loss of electron, cation is formed by the loss of electron, and simultaneously there is a formation of Cl minus, which is formed by the gain of electron. Now since we have Na plus and Cl minus, one is cation, another is anion, there will be a formation of ionic bond, force of attraction between cation and anion Cl minus, and there will be a formation of ionic bond. Now what happens in case of diatomic molecule like chlorine, like nitrogen, like fluorine or hydrogen or oxygen? What happens in case of the diatomic molecule? See, just in order to get the stable outer octet, in this diatomic molecules, this condition of the stability with the complete octet is achieved by the sharing of an electron pair between the atoms, which is nothing more but covalent bond scheme. So in the covalent bond, atoms share electron and bond is formed. Lewis also gave Lewis dot symbols to represent atoms. Lewis symbols, they consist of element symbol surrounded by the dots, like this one. These are the dots, Lewis dots. And what these dots represent? Students, these dots represent the number of electron present in the valence shell, means outer shell. So these symbols show that the outermost shell electron, they take part in the formation of chemical bond. So now we can say that inner electrons in the covalent bond, inner electrons never participate in the formation of chemical bond. Who does? If they do not participate in the formation of chemical bond, then who does? So basically, outermost electron in an atom, which are also known as the valence electron, they does. The outermost electron in an atom, which are also called as the valence electron, they does participate in the covalent bond formation. So I hope now this is clear to you. Now, what is the significance of these symbols? The number of dot around any symbol of atom, whether it is carbon or it is oxygen or nitrogen or whichever, it is equals to the number of valence electron, which means, see, in the carbon belongs to which group? Group number 14th, or in the old nomenclature it is 4th A. In this group, members of this group, carbon, silicon, germanium, members of this carbon family, they contain 4 electrons in their outer shell. So in order to make the Lewis dot formula of carbon, we will draw the carbon in the center, and then we will draw 4 dots around the carbon central atom, which simply represent formation of 4 valence electron. These 4 valence electron will further participate in bond formation. Similarly for nitrogen, now you see, for nitrogen, which is member of 5th A, group 15. In the group 15, how many outer electrons? There are 5 outer electron. So these 5 outer electrons of nitrogen are written over the nitrogen like in this manner, called as Lewis dot structure. It is dot structure. And this is how, by calculating the number of valence electron, it helps us to calculate the common valency of any element. Suppose you want to know that which element will have which kind of valency, then you have to draw the valence electrons. Alright, the picture you see here belongs to the 𝕍𝕆𝔼𝕆. In 1916, he put forward the theory of bonding based upon the electronic concept. So basically he gave the concept of bonding which was based upon the fundamentals of electron. What was associated with this theory? According to his theory, the formation of bond depends upon the number of electron present in the outermost shell. See, in any species, how many number of outer electrons are present? Basically, this is very important question, because answer of this question will determine the direction in which this molecule will lead during the bond formation. Whether it will go towards the ionic bond formation or it will proceed towards the covalent bond formation, that will be decided by number of valence electron. Alright, so according to this theory, the formation of bond depends upon the number of electron present in the outermost shell of an atom. Outermost shell is also called as valence shell. Outermost shell is also termed as valence shell. So here what important for us is valence shell. He observed that the atom of noble gas means helium, neon, argon, xenon, krypton, radon, which were previously called as inert gases. Nowadays, rather than inert gas, they are moreover called as noble gas, because the word noble means less reactive, while inert means no reactivity. And now we know, since we know that alkali metals, they also form compound, and inert gases also form compound. So now we cannot say that they are inert. Yes, they do react slowly. Yes, they do not react as like the other species, but still you cannot say that they never react, because yes, they do react. So they are nowadays called as noble gases. So we found that atoms of noble gases are stable. Basically we found that the atoms which belongs to the noble gas are stable. Question is, why? Why the atoms of noble gas configuration are stable? And the reason is very simple, as they have 8 electrons in their outer shell. Being 8 electrons in outer shell became stable. So now we came to know that all these species which will have 8 electrons in the outer shell will be stable, and that is called as octet rule. Although there are few exceptions of this rule, as like helium. I'm not saying that helium is not stable. Yes, helium is stable, in fact very stable, but it contains just 2 electrons in the outer shell. Yes, I call helium as an inert gas or the noble gas, but it is not having 8 electrons in the outer shell, just 2. Rest inert gas have 8 electrons in the outer shell, but not helium. So the atom of all other elements which do not have 8 electrons in the valence shell. Now it is not necessary. Do you think that it is necessary that all the atoms will have 8 electrons in the outer shell? No. Some will have less than that and some will have more than that. And if it is less than 8, it is called as incomplete valence shell, incomplete octet, and of course it is unstable. But if sometime species contain or possess more than 8 electron in outer shell, this condition is also unstable and it is called as expansion of octet. What it is called? Expansion. Expansion means having more than 8 electron in outer shell is technically called as expansion. So here is the octet rule. Atom generally tends to have the 8 electrons in their valence shell or the outer shell. What they tends to have is to generate 8 electrons in their outer shell. Atoms, they can complete their octet either by the transfer of valence electron. If there is a transfer of valence electron, students, like I told you earlier, there will be formation of ionic bond, or they can share the electron, and sharing of the valence electron will lead to the formation of covalent bond, and this rule is called as octet rule. So which one is octet rule? Having 8 electrons in the outer shell is called as octet rule. Again remember, octet means 8 electrons in the outer shell. Hydrogen and helium, they never follow octet rule. They follow doublet. Rather than octet, they follow doublet. Doublet means having 2 electrons in outer shell. So it is the special case for helium and hydrogen, as they have 2 electrons. Guys, you know why they have just 2 electrons in the outer shell? Because they do not have 2p subshell. Hydrogen and helium, they just have 1s. They don't even has 2s. So they can accommodate only 2 electrons in their outer shell. Now according to the doublet rule, there should be 2 electrons in the outermost shell of an element to be stable. And yes, they are stable, especially helium. But apart from the helium, all other noble gases, they contain 8 electrons in the valence shell, like neon, argon, krypton, radon and xenon. They all have 8 electrons in the outer shell and they follow the octet rule well in advance. Alright. Now, in this unit further, now we will go towards the major form of the bonds. What kind of schemes we have for the bond formation? So in this unit, chemical bonding, like I said, I will tell you about so many different kind of bonds, but these 2 bonds are the most important bonds of the entire chapter. One is covalent bond and another is ionic bond. Covalent bond is a mutual sharing. It is just mutual sharing. You gave 1 electron, I gave 1 electron. 1 electron is given by A, 1 electron is given by B. Now this is the pair of electron which is called as bond. Question is, these 2 electrons of the bond belongs to who? They belongs to A or they belongs to B. In the covalent bond, there is a mutual sharing, students. Again, listen the term mutual sharing. In the mutual sharing, this electron pair which is between A and B belongs to both of the atoms. It is not like that it belongs to A only or B only. This is called as covalent bond, sharing of electron, mutual sharing, sharing with one another. While in the ionic bond, which is altogether a different scheme, what happens in the ionic bond? You know this. In the ionic bond, there is a formation of ions. What ions does? How they are formed? Ions are formed because of the transfer of electron from one atom to another atom or element. It is also called as ionic or electrovalent bond. In this ionic bond, one atom or one species loses its electron, and the electron which is lost by this species is gained by some another species X, and eventually it will form X minus. So there is a formation of M plus, which is of course cation, and there is a formation of Cl minus, X minus, which is definitely anion. So the force of attraction which works between them is called as ionic bond, because cation formed by the loss of electron, anion formed by the gain of electron. They attain charge also, plus and minus, and now the force of attraction which coexists between them is called as ionic bond. Later in this unit, I shall explain you about these two bonds primarily in detail. So in the coming class, I'll tell you about the ionic bond and formation of ionic bond and the factors which are related with the formation of ionic bond. Till then, take care and keep studying.